In Chapter 4, you will look at some basic characteristics of probability. Now, most of these you've probably already come across before. There's a really nice little summary here, and it covers all that we're going to be doing in this chapter. So it's looking again at the formula for calculating the probability of an event, and some of these terms I've outlined below. So if you're unsure about what an event is at the moment, I'll cover that for you. If you're unsure about what an outcome is, I'll cover that as well. Recognise that the numbers for the probability for an event range from 0 to 1, unless of course we're converting our probabilities to percentages, then they go from 0 to 100%. And we don't ever talk about a probability any more than 100%. We don't talk about a probability any bigger than 1. You'll use some tables and tree diagrams to get results organised. We'll introduce the idea of complementary events. Performing simple events to create a value for the relative frequency, and then obviously compare relative frequencies with theoretical probability. Okay, some of you will already know that an outcome is the result of an action. So if you roll a dice, as you can see there in the diagram, roll a dice, then an outcome could be getting the number 1. A sample space is the list of all possible outcomes. And if we were listing the sample space for a dice, it would be 1, 2, 3, 4, 5, and 6. Then we have something called an event. An event is, as it says here, a group of outcomes. So if I'm talking about a dice, a group of outcomes might be an even number. So we roll the dice to achieve an even number. So there is more than one outcome in this event. This event covers 3 outcomes, getting a 2, getting a 4, or getting a 6. And we could talk about the probability of getting an even number. So let's move on and have a look at actually calculating what we refer to as theoretical probability. In theory. Theoretical just means in theory. What should happen? We know, as I'm sure most of you have played with a dice, we know that what we're going to see in theory doesn't always eventuate when we actually perform rolling a dice. So we would expect particular outcomes or particular results, and we know that doesn't happen. You might have thrown a dice more than 6 times, but in theory, if you've thrown it 6 times, then you should have at least thrown 1 6 in those 6 rolls, but we know that that doesn't always happen. We have another situation where we don't always get what the theoretical situation tells us, and that's because sometimes, for example, maybe a coin or again a dice could be biased. So bias just means that an outcome, not all outcomes are equally likely. They're now not equally likely. Now, we cannot calculate using our formula the probability if we have a biased dice. Now, something might be put on the inside of the dice so that it always falls, it's heavier on one side, so it always falls one particular way. Or a coin might have been tampered with, and again, so that it tends to fall heads side up all the time. Now, those situations, our formula that we're going to see for probability certainly doesn't work. We are definitely only able to use our formula to calculate the probability of an event when the events are equally likely. So what is that formula? That formula is the probability of any event is the number of times the event occurs. So when we look at a dice, the number of 4s is only 1, over the total number of outcomes, and the total number of outcomes on a dice is 6. So the probability of getting a 4 is 1 in 6. Now, you will also see some other situations where events are not equally likely. So I'm not sure if you're aware that in the English language, the letter E occurs more often than any other letter. So if I was just to look at a page of writing and say, well, the probability of getting the letter E, since there are 26 letters in the alphabet, and E is just one of them, then the probability should be 1 in 1 in 26. However, that we know that's not the case, because E occurs more frequently in words. So that's just another added complication of a situation where the events are not equally likely. We're certainly not going to be dealing with those in too many cases. It may come up for you to consider, but just be aware they are examples where the outcomes are not equally likely. So, questions often also involve a pack of cards, and so you need to be familiar with cards, and the questions are always only referring to a standard pack of cards. Some of you might be familiar with other packs of cards that have cards in other than what I've listed here. So some of you might be aware that you've played a game and the pack of cards have contained a joker. We don't consider joker to be part of a standard pack. So all questions in probability about cards are referring to this standard pack, and please familiarise yourself with those. These we know as the picture cards. The Jack, Queen and King are the picture cards. The number 1 card is the ace, and there are 4 aces, as you can see, and then we just start the numbering 2, 3, 4, etc. up to 10, isn't it? Yeah. Okay, I will stop the video there and